Hello. Today I prepare for you a presentation about classification on video stream with GPU computing on OpenCL, and this actually will be my PhD update from the March 8th, 2020, which is uh, one day back, and my first important goal for this all work was to create artificial intelligence system that will be able to pre-label at least 80% of test car video log frames, right? So you can imagine you have car with cameras and you want to detect what's on the video on each frame, right? So my solution will be based on darknet convolutional neural network CNN and leverage YOLO model, you only look once, but I want to make the step further. So I would like to basically port, that was my goal, to port CUDA version to the OpenCL version. That's very important to me and to community, I believe, because CUDA is closed and dedicated only for NVIDIA graphic cards. So here you can find the model and imagine how deep neural network works and how it detects the car track, van, bicycle, and other things. And to give you understanding, this is recorded on my car when I drive to work one day, and you see cars. Basically, the most important to detect there are cars, maybe some traffic lights and other things. So this is not easy task, right? But with YOLO, CNN, and darknet is easy. So imagine we have this frame, this image that is in the original CUDA version created by Joseph Redmond and post on the GitHub. And my very early version of the OpenCL implementation work like this. So you have the basically command on the top and the output of the command, and of course detection in the picture with some percentages, time of detection, and things you might check. Now this work needs some tools. So first, strong workstation, a small lab for the coding purpose, a good mathematical device for calculations, and a good important to the every coder's internal idea for the development in modern fashion, right? So this is basically my investment. So this is 2 Titan RTX I bought to make this all work, and I also invest later on with on the AMD Radeon 7 2 cards and my modern workstation with the NVIDIA GPUs looks like this, and with the AMD 2 GPUs it's like that. Now I'm recording, so you can always check step by step, but this is the specification. It's quite strong workstation with a lot of things included, but I'm really proud. I built by myself by many years to some savings and build from step by step to have such power and a lot of storage and all that. My development lab is very small because I'm using MacBook Pro 13-inch and the external GPU from Sonnet, and that's make possible all that work on OpenCL because I face the problem that on Mac regular darknet doesn't work. My good calculation device is the Texas Instrument T-Inspire CX CAS. It's very nice and very famous also, one of the top calculator of the world right now. As idea, I'm using C-Lion from JetBrains. It works very well, very smooth, and I love the debugger capability really, and making the profiles for the different test scenarios. This is producer, and the software is C-Lion, as I said. And if you think about any company that want to use that type of detection, they need to train, preprocess, improve, and preprocess again, right? So it need to be iterative process for improving the YOLO models that were be trained, because every train process starts from random weights, and they are improved in neural networks during the process of training. But you have the idea that some models and some created weights for the model are incorrectly detected, right? So you need to sometimes create many iterations once you until you find the good working solution. And about 2 years ago, NVIDIA introduced a DGX station, and I said, wow, when I saw it for the first time, it was, impressive power workstation to me. Now, here's the very impressive specification, almost 2 times more NVIDIA CUDA cores than I have in my workstation, but my workstation is also quite fast. I want to give you only one reminder that NVIDIA, based on the Linux, and this DGX station use host OS that is Linux based, and they use the NVIDIA Docker, which is very nice and very smart, that you can just install the stack of the Caffe or TensorFlow when you need it. Now, this is something that make really impression on me. Darknet created by Joseph Redmond, I mentioned before. This is really, I want to thank him to make such impressive projects. You see a lot of stars, a lot of watch people, a lot of forks, but also a lot of issues. Now my version is just started, is about 2 years on the GitHub. I only get 80 stars, 12 watches people, and many issues during the development time, but on each free open right now. About me in the internet, if you write my name and followed by the blog keyword, it detects and first rank the darknet in OpenSea solution, right? And I think it's nice because Google already detect interest on my project. I'm really happy. And this blog, also my statistics from 2019 shows that this entry, darknet in OpenSea, is on the 3rd place, right? And you see the top 10 countries, but in fact, I have guests from around the world. So I'm really happy also to make this blog as a place for kind of sandbox for my publications on that PhD work. I train basically on the blog what I can publish, also my English grammar and so on. If you look on the darknet OpenCL in the internet, you can find that there are also other implementations created by others, by other teams, and I try to compare 3 I found, and to be honest, YOLO first, YOLO 1 training doesn't work anymore on my solution. It worked some time ago, but not now. But I tested performance recently, and the training of the YOLO 2, YOLO 3, and the demo video log from my cars shows me that I'm basically achieving better performance, especially in training. And to remind you, my goal in a little bit funny way is that I want to replace darknet, which is closed for the CUDA and NVIDIA provided graphic cards, to all of the world and change it to the lightnet, right? But I don't plan to use this logo type I created as a kind of for fun only. I don't want to take from Joseph Redmond his logo, which is very nice, and don't want to profound it, right? Now, this is serious work. So if you want to port from CUDA to OpenCL, this is really serious work, and you have to spend a lot of time. So you can see number on the bottom, number of files I change, additions, deletions. So it was really hard, and I achieved only 18 stars. But fingers crossed, it will be better during the time. And now, when you want to port darknet from CUDA to OpenCL, you don't have to, because I already did, but any type of that software, I think there are a few steps. First, you need to read and understand code of darknet in CUDA or any other projects. And basically what I'm saying to young programmers, you have to read and write, repeat 10 years, right? And then you can be good in the coding. If you later on, after this, be familiar with the code, experimenting, playing with the code, I delete all CUDA only code from the repository, right? So C compiler wasn't happy. Then I create the OpenCL abstraction similar to CUDA abstraction with empty methods, and put them everywhere just to satisfy the compiler. And second thing, I create the abstraction for the CLMEM, which is virtual memory in OpenCL abstraction. In CUDA, I just pointer to the float. I mean, it looks similar in the code. In OpenCL, you have this abstraction. So why this abstraction? Well, I want to combine two things. First is the memory in computer, and second, memory in video card, and make the pair, right? Make the pair and make sure that I transfer only between those two. Now, I had to also replace all the GPU fields that were, as I mentioned, float, pointer to float, to the CLMM extension on the everything, and then compilers start working. So I was able to test and improve the OpenCL kernels, and most of them, especially for basic linear algebra subsystems, were in this project, not the project in the GitHub that you can find, was very hard. So I just analyzed what was in the C code for the CPU, and then create C code for the kernels for OpenCL, and it took a lot of time. So at the beginning I have recognition, recognition what is on the picture, and I was happy, but training took me about 1 year of experimenting to achieve the training capability in this. So test, improve, fix, measure, fix, and so on. Test, measure, improve, and till the end. So that was my work scenario. And I want to provide you one problem to check. It's already solved on my blog, so you may check it in the comment. I post the solution, but this is something, fast kernel. The problem is that this kernel basically need to the number of the I is very small. So you introduce the t integer to make it faster. So you basically add more threads to computation. So you can imagine that e is from 1 to 16 only, but iteration spatial, for example, a parameter right there, is very a lot number. So if you introduce skipping by the spatial with the tuning way, right, you have much better performance, and that need to be achieved, and is achieved wrong by say competitors of my work. And what I did is actually creating only one parameter with this comment that it cannot be more than one, but you need to guess why. And I figured out how to make it only one parameter, decide how many threads we want to introduce to fast variance. And this is part of code I'm really proud of, because it saves a lot of time. But you need to figure it out. You might did this exercise on CPU and GPU, especially you may look on the GitHub for the for me and for one of my project about GPU computing in general, and there are some sandbox tests that you can leverage and try to figure it out. What's the problem with this? Why, if it's not one, it doesn't work, right? But if you are lazy, you can just look on my blog and find in comment the solution itself. Now, what is Smart 8 update? First of all, yesterday was the International Women's Day, and I want to say for all women, all the best, all happy, especially my two women, the little one and a little bit older one in my closest family, but also in entire family and entire world. So all girls, all ladies, all the best for you. Now let's keep up for my PhD work. So first thing, I test heavily performance of the all solutions. So STEP, CPU, NVIDIA, AMD with the two flavors, with the OpenCL CL Blast and OpenCL CL Blast, right? There are two solutions that can provide for this project computation and multiplication of the matrices. So if I want to measure all that, and you can see on the comparison that NVIDIA CUDA is the best in this comparison. CPU is a lot of time, and keep in mind that this axis, x-axis, is the logarithmic. So you can see that even if processor is only a little bit faster, it means that it is 10 times more faster, slower, right? Slower, because what is small is the best result. Now, also I check the kernels itself. So I prepare the way you can just by changing in compilation the flag, and then you can measure each kernel that was used and look for the bottleneck. So you can see, for example, CL Blast for the OpenCL AMD has a lot of ticks to, I believe, 20,000 ticks, and that's the problem, right? Other were fine, but this one was problematic because of the probably big matrix to the multiplication. Now, this is a comparison of the Eurofree training. What's the loss, right, during the 10,000 steps, and then you see the shape of this, that you start with the big loss, and on the beginning is slowing down very quickly, and later is slowed down only a bit, right? Because the YOLO-free is very deep neural network, is I believe 53 convolutional layers, right? Or I think 53. Okay. Now this is OpenCL loss. It takes more time, but on the same, you see the same tendency, the same way this lost, the error basically is slowing down. Now, to update you on the coding, I change the permutation of random sets for training, to be permutation, so not random, but be the permutation. And if you have like 100 pictures to fit the network and train, I want to make sure they are unique from, for example, 5,000 examples, right? Not 5 times the same picture, to not, and I think it may improve the overall solution, but it's exclusive internally. I not publish it yet. I play with the step 16 activation and gradient functions, but this is a little bit secret for now. I don't tell you what is about yet. And I tuning and training, tuning of training with this, what you see probably as a code example. That tuning was in place, and that really improved the performance of the training. I decided to buy DeepL Pro solution. This is English translator basically, and I think my English is still need to be is quite nice, but it still need to be improved. So I want to learn from translating English text to Polish text, and I think this tool is very nice as well. Also, update from the internet. I achieved 80 stars, as I mentioned before, and I'm really happy of that, really. And I'm working for the first publication with my mentor, Professor Jacek Izydorczyk, from university I'm studying and want to achieve PhD. So it is in approval process right now, and will be available soon. This is basically a little bit secret, so don't tell anyone. Just kidding. This is Qt, and I want to use for my PhD application UI Qt as a based, very good portable C++ solution. So in time when we have already like window forms or Java possibility to make the user interface and graphical user interface on the desktop, the Qt was the first, and it's really good. And it can run on the LG TV, it can run on the Linux, Mac, Windows, and many more platforms. It involves about 20 years ago. I tried to use it, but I was simply not as smart as I expected to leverage that very good library. So you can remember Qt and look for the Qt library for UI UX. It may make your heart much easier when you create the UI project for your applications. Now, for my PhD, this is the start point. I just started, make the notes, and I'm using the TechMac. It's the editor with the Visfig. It means what you get is what you got, like in Word, basically, but it's based on the LaTeX, and it's really nice looking. You can create a book like looking at a PDF after creating it with the TechMac. So I want to make my PhD in Polish, start in Polish, then translate to English with DeepL, as was mentioned before, but I want to use this editor to make it nice, right, and professional. Now, this is my workstation, and what I achieved so far will be present on this video. So I start the series basically on this experiment that was recorded, and then I want to show you that this car, I remind you, is full HD video, 60 frames per second, so it's kind of impossible to compute right now yet with our graphics card. And on my workstation with the Titan RTX that I told you, I think they are very fast. That was detected. So you can see cars close to us as they are detected. And in my solution, the frame per second is in the corner, and the percentage of each object is, near the name of it. I change it because I think that is easier to understand what's going on the image, and also it's faster because you not print out on the console at the same time you computer every frame, and that was given me by my good friend Filip Rudzinski, and he find out, this is, you can improve. I mean, this is a professor, so I should say that with this, but he helped me and find this idea to improve the performance to 21, 22 frames per second sometimes, but basically 20 is achieved. Now to create this video, I'm using SJ Cam, 2 cameras. If you are interested how to record, that's basically I'm using. And I want to remind you that vision without action is a daydream. Action without vision is a nightmare. So I'm trying to act with vision and action at the same time. Summary. So I tell you so far about the goal and solution, about necessary tools, about process change, professional hardware, NVIDIA DGX, some update on the internet, and porting CUDA to OpenCL receipt, right? And my PhD progress. But there is one more thing. And I would like to point out that you can, on the Mac Pro 2019, use only OpenCL version, right? It natively support only OpenCL, I mean still, on the macOS Catalina is deprecated, but it's working, and you can only use darknet with OpenCL. You cannot use CUDA version without hack the system. And this is the Mac Pro 2019. It's very impressive, and the specification is really good. So you may see this is something amazing, but also price is very amazing. But let's imagine for a moment that we don't need as beautiful case. So maybe we can build something nice and smaller, and try to divide by 2 all specification that is created. So this is the specification we can achieve. And what about price, you may be wonder? Well, without additional keyboards and trackpad and mouse, it can be $3.3 thousand. So completely different price, right? And I built it. I built the macOS Catalina, and then I found also that on macOS on AMD, OpenCL works flawlessly, right? Really flawlessly. So you can see that it beat even a CUDA version on the computation and training process. And I prepared the quick presentation for you about how it works on the my daughter call it Hania PC, which is Hackintosh really, but Hania is the name of the lady in Poland. As you can see, I need to maximize, and we achieve a little bit better performance on the same video than on the Titan RTX on my workstation. Titan RTX 3000 card, $3,000 card with Radeon 7 in a Hackintosh, $700 card, right? So you probably feel the difference, and this is really amazing. For me, was the discovery of the day, and yeah, I'm really happy of that. So basically, that's the log, very similar, but a little bit faster, even of and you may compare such strong things. At the end, I want to show you references. You may check them later on this video. And thank you so much for all your attention. I hope you like this video. You may just give me kind of like or star or whatever you want. I did all that because of curiosity, of my passion, and I'll be really happy to achieve PhD in next 3.5 years. So again, thank you so much.